Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to find the OH concentration and pH of a basic or strong base solution. So basically this is pretty easy and straightforward. You're just going to use the equation of Kw is equal to the product of H plus concentration or hydronium ion concentration and the hydroxide ion concentration. So basically the equation is Kw, which is 1.0 times 10 to the negative 14, and that's going to be equal to the product of H3O plus concentration multiplied by the OH minus concentration. And so if you're given one of these, right, then you can find the other. So here we're given the concentration of KOH, and we're given the concentration of strontium OH2. So we're going to deal with each of these separately. So the first thing we need to do is find the concentration of OH. Since these are strong acids, they're going to dissociate completely in water, so we can easily figure out what the concentration is going to be. If you've got a strong acid, a strong base with only one hydroxide ion in the formula, then whatever concentration of the base you have, that's the concentration of the hydroxide ion, because it's just going to dissociate completely. So you've got KOH, if I draw it down here, KOH is going to dissociate completely into K plus OH minus. So for every one of these that breaks apart, you get one of each of these. So if you have 0.255 molar of this, you're going to end up with 0.255 molar of this and 0.255 molar of that, because of the complete dissociation of all of the molecules of KOH, or the formulas of KOH. So since we know the OH concentration, then we plug that in and we use that to solve for H plus. And then we can use the H plus concentration. We can take the negative log of the H plus concentration or hydronium ion concentration, and that'll give us pH. All right, so let's go ahead and solve this. So we'll get 1.0 times 10 to the negative 14 is equal to H3O plus concentration multiplied by 0.255 molar. Divide both sides, and we'll get our H plus concentration, and our H3O plus concentration is equal to, if we calculate this out, it comes to 4.44 times 10 to the negative 14 molar. And we only allowed 2 sig figs. Okay, so then now we take the negative log of this. If we take the negative log of this, we get, for a pH, 13.35. So the pH then, if we take the negative log, right? So we take the negative log. This is equal to the negative log of this concentration, 4.44 times 10 to the negative 14. And then that pH is going to be equal to 13 point, I think I said 35. Okay, so again, I want to point out that whenever you take the log of something to figure out the number of significant figures, you have to remember that whatever number of sig figs I have in the number that I'm taking the log of, it's that many decimal places I should have in my answer for the log. So here I have 2 decimal places. I'm only allowed 2 decimal places. I have 2 sig figs here, right? Because I have 3 here and I have 2 here. The least number is 2, but I keep an extra digit to avoid rounding mistakes. So I have 2 sig figs here. That translates into 2 decimal places for the answer of the log. So I have 2 decimal places here. So that's the answer. That's the pH. Okay. So what about the next one? B. We have 0.015 molar SR. So again, we need to write out the balanced equation. So here again, it's a strong base. But now we have 2 hydroxides for every 1 unit. So when this dissociates completely, it's going to dissociate into SR2 plus 2 moles of OH minus. So for every 1 mole of this, it breaks up into 2 moles of OH. And so this is our balanced equation. So we're going to have double the amount of our concentration of OH. So if we're starting with 0.0015 molar here, then we're going to double it. We're going to have 0.0030 molar there. So this is the concentration of OH plus, or OH minus, that we're going to have in our solution. So now we know what the OH concentration is. We're going to take the equation here again. So 1.0 times 10 to the negative 14. That's going to be equal to the H plus concentration, or H3O plus concentration, multiplied by 0.0030. Divide both sides by 0.0030, and the concentration of H3O plus becomes, 3.3 times 10 to the negative 12. So we get 3.3 times 10 to the negative 12 molar. And then again, we're going to take the negative log. So if we take the negative log of this, we get a pH of 11.48. A pH of 11.48. And once again, I'm taking the negative log of this. So I have 2 sig figs here. So that should translate into 2 decimal places for my answer for the log. So here I take the negative log, and I get 11.48. I have my 2 decimal places. So this is equal, this is the pH of strontium hydroxide. So I hope this was helpful. That's how you find the pH and the hydroxide concentration of a strong basic solution. If you like these videos, please like, share, subscribe, hit the notification bell, leave a comment into the comment section. Thanks for joining me, and I'll see you next time.